So our today's topic is compiler directives in Verilog. So in Verilog we are having some compiler directives which every languages have, like anything like in C language you can take example of C language, tick include we will include, so that your printf and scanf function will run, because that compiler directive will tell that this is there in some memory which is stored and this is a proper function or proper thing to use, proper code syntax. So in module and everything, these are compiler will have this information. Okay, so we are giving some additional information that how our code should run, what should run, what should not run, something like this, at what time it should run, what is the time scale. So these things we are giving instruction with the help of compiler directives. So compiler directives are special instructions that tells the Verilog compiler how to process your code before simulation or synthesis begins. So this is our compiler directive. Now let's move forward. They will not represent hardware. As I said earlier, it is on compilation phase, so it is not representing any hardware. It is just giving instruction to our compiler. Do not generate any logic. So giving instruction means there is no logic in this, just giving instruction. Instead they control how the compiler. Okay. So with the help of compiler also you can include files, define macros. Mostly you will see this word in our UVM. I will create this separate playlist for UVM.
Hit subscribe, like, and comment now. Let's begin the journey of verification.
And ignores part of codes and set simulation behavior, controls timescale as I said earlier, some skills are set, manage conditional compilation, which we will see now. Tick include another file. So this is first and most used is our tick include, which will include some files inside your code. For example, if you have created one file with top, you can say top.v, and other file is our s.v. so this s.v you need in your this file, because you have written some parameters here which you need in this file also. So you can write tick include here and file name s.v, and this file will be included. So this is the function of tick include, used to include header file such as macros, parameters, tick define, etc. Whatever you need to include, you can include. So there is one example, like this is one file name def.svh. This is also compiler directive which we will see afterward, but this file has these things, so you can understand that s.v have these things, and this is our top file, and you want to include this thing. So include this thing or file name and module, and you can write, you can use this with 8 will be here. So this is function of your tick include with the help of your tick define. Now tick define. So tick define create macros. First of all, tick define can declare one. For example, I have used this example many times, like pi 3.14. So this value you can set by parameter, but also you can tick define this, like we have defined our width previously now. So you can write define, okay, and 3.14 pi equal to. So these things you can declare with the help of tick define. But another example is this one, like clock period is 10 and you have declared this clock here, you have created logic. Now you have converted this logic to a macro. So for example, if define add a comma b, a plus b, so assign some add. So this logic a plus b is also our compiler directives. You can use like tick add, this one add, and you can use this, and previously also you have to use that tick with here, okay, because this is inside our tick define. So these macros are created with the help of our tick define. Now common Verilog compiler directives have another thing is our ifdef, else, endif, and conditional compilation. What is this? This is nothing but if else statements. Okay, so first of all is define debug is our, we are declaring some debug as our variable, you can say, for files. So this is something like this. This is one file, you are writing if, but in place of if we are using ifdef, means tick ifdef, and there is one another file else if, you can say tick else, So this else and this else. So you are saying if debug, this file will run. If not, then this file will run. And this is where you will set in your command line, you will tell that this debug, you want debug means this file. If you say we don't want debug, just don't write debug and this file will run. Similar thing is happening here. If take debug, then this statement will run, else this statement will run. So this is for statement, for example display statement or this statement, but you can use this whole file and write if def, and you can use another files and you can write else if. So two files you can also have conditional statement for two files. So two codes you can run different. For example, some code is over sum and some code is over difference. So some code we will run when you will write sum in your command line. Difference code will run when you write difference in your command line. So you can control your simulation with the conditional compilation. Okay. Now next is our timescale, which is every time you will see in Verilog system, Verilog UVM also, that you have to declare some timescale that at what your simulation is running on nanosecond, femtosecond or something. So this is a common example, define time, unit and precision. So this is 1 nanosecond, means your main scale is like 1, 2, 3, 4. So this is nanosecond scale, okay. And precision is like 1 ps, means picosecond. So in between there is a 1 ps, like if you are using real time to take that input, so you will see 1.1. so this one is over ps, means picosecond. So this is our time scale. You can define these things. And default net type enforce wire type rules. So this is another type of our, you are just declaring that what should be default. Like default is none, then there, for example, if you are writing a in module and just input a, so by default its data type is wire, right? So we are using none, so block the wire creation. Okay, now you have to declare wire, then only the wire will be there, otherwise it will be not. So there are different types of compiler directives you can use. You can just search the compiler directives, read its definition, and you can directly use it. So thank you, and you can comment on my videos for whatever videos you want.
Please Lord, give me a sign, a sign.